Hi, everybody. Okay, so this is part two. Let's talk about compound transformations. Like performing compound transformations, kind of like on School G, would be tough. And so the way you're going to probably see this question is I'm going to give you a compound transformation and then ask you what's the sequence. Was a sequence of transformations that actually carried the original pre-image to the final image. Now, the first hurdle in that, and it is a small hurdle, it's not one that you guys haven't seen before, is we have to know our starting triangle and our ending triangle, our pre-image and our image. There's no big secret here. If you look at the coordinates and how they're listed, here I have A and here I have A double prime, which means we're going from the blue to the pink. The other way you might see this told is like we might say, hey, you're going from triangle ABC to triangle DEF, and that'll give you kind of a direction. The importance of knowing that right off the bat is that we can eliminate some choices that we know are bad. If we're going from the blue triangle to the pink triangle, that means we're definitely shrinking, we're reducing through a dilation. And if we're reducing, we can throw out two of the answers right off the bat. Here we have a scale factor of 2. Here we have a scale factor of 2. Scale factors of 2 are going to enlarge, not reduce. And so I know it can't be this one, and I know it can't be this one, okay? Other than that, there's many different ways to figure out which of the two remaining choices are going to be correct. One way is brute force, and what I mean by brute force is we just do the thing, right? And we figure out where it ends up. So we just do what it says for B, and then we do what it says for C, and only one of the two answers could possibly be correct. The finesse way is just thinking, without doing it, just kind of thinking, well, to get the blue triangle to the pink triangle, I'm going to have to at least do these things, which of what my choices offers that. Let me explain what I mean. Okay? So let's just say we take point B, for example, right? And we just do what it says for number B. We reflect over the y-axis and then reduce by a half. Well, B will end up here at B prime. Over that y-axis reflection, because remember a y-axis reflection is going to be along this axis, it's going to flip left, right, and we're going to end up at the coordinates 2, 2. Well, if I have coordinates 2, 2, and I reduce by a factor of a half, I'm dividing each one by 2. So 2, 2 becomes B double prime 1, 1. Okay, and so B worked precisely as we said it should work. And if B works, let's see if C does. Okay, so if I take C, negative 8, 2, flip it over the y-axis, I end up at 8, 2. So that's going to be C prime, 8, 2. And then if I reduce it further by a scale factor of half, I cut those coordinates in half. So 8, 2 becomes 4, 1. Oh my goodness, look, C prime is going to be 4, 1. Excuse me. That's a 4, 1 columns. There we go. Okay, and so it worked for B, it worked for C. It's probably going to work for A, but let's go ahead and check it. If it works for 2, let's check if it works for the third one. We have negative 8, 1, 2, 3, 4, 5. And so we're going to go over here to 8, 5. So what's that? A prime, 8, 5. Well, if I cut 8 in half, I get 4. If I cut 5 in half, I get 2 1/2. And so this one has to work. Okay? That's probably the best strategy. Know what the dilation is going to be and eliminate a couple of the known bad choices. And then from there, try to figure out how to move points, single points. Let's try that again. Okay, so let's slide down to this guy. Okay, so first big observation, I'm going from blue to pink, I'm enlarging. I look at the coordinates again, I have A, B, C for my blue coordinates, A, B, C primes for my pink coordinates, and so I know I'm enlarging. That tells me I'm multiplying by a number that's larger than 1. Okay, and so right away, I know this can't work because a scale factor of 1/2 will reduce. Same thing here, scale factor of 1/2 will reduce, and I'm definitely enlarging here. Okay, and so now I have to figure out which of the two remaining choices is it going to be. Now, having said that, I'm going to take the same strategy. I'm just going to pick a point, I'm going to start to move it around according to what it says, and let's just see if it even works. Okay, so checking A. First reflect over the y-axis and then dilate by a scale factor of 2. The y-axis is this guy right here, so it tells me I need to flip it to here. Okay, well right away I can tell that's not going to work because if I flip it to the first quadrant, to the upper right, and then dilate it, it's going to stay up there. So I know this can't possibly be the right answer. Now that doesn't mean we should just blindly circle C. Let's check C also. Let's take this point B reflected over the x-axis. This guy is the x-axis, right? So we're going to flip down. So we're going to flip this way. So B is going to end up right here to B prime. So it's going to be -2 comma -1. And then we're going to dilate by a scale factor of 2. That means I'm multiplying everything by 2. So -2, -1 becomes, oh look at that, -4 comma -2. Let's check the other points as well. So A flips down to -4 comma -2, and then it doubles, it's going to be 8 comma 4. Yep, that's going to work. And so C is going to flip to C prime, -5 comma -1, and then we double it, that should be -10 comma -2, and that's exactly where it ends up. So I'm fairly certain C is going to be our correct answer, okay? And so again, eliminating some bad choices, some distractors as we call them in the math business, and then working, just like kind of moving points around according to the transformations. Something you've definitely done 150,000 times, right? Okay, so example 3. Okay, so again, we're going from blue to pink, A, B, C to A prime, B prime, C prime. Man, someone was really nice and kept the colors like pretty consistent, so it's easy to tell right away, huh? So we're enlarging, and so right away, I know it can't be this one, and I know it can't be this one, because the scale factors of 1/3 should reduce. I want to get larger, and so let's just now test to see what's going on. Okay, I'll be honest, right now I can see that we're going to have a y-axis reflection. That's not going to work because that's going to flip everything this way, and so I'm fairly certain that can't be the right answer. I'm fairly certain this has to be the right answer, but let's just go ahead and like do it, right? So if I take like point C and I multiply it by a factor of 3, that's going to be 3 comma -3, just multiplying the x and y by the factor of 3. So C prime is going to be 3 comma -3, and then if I flip it over that x-axis, like it says to do right here, x-axis flip, it should end up 1, 2, 3 to the axis, 1, 2, 3 away. Yep, that lands right on the C prime. Okay, B prime, 4 comma -1 times 3, that becomes 12 comma -3. So 12 comma -3, here it is. B prime, 12 comma -3. And then if I flip it up over that x-axis, it ends up right on B prime. So we should be good here. Right? And so even though these questions look intimidating, if you kind of just use your knowledge of geometry and how things move around and what you know about dilations, they're actually pretty easy to figure out. Let's look at this last one, okay? So A, B, C to A prime, B prime, C primes, that's going to be a reduction. So we know the number has to be less than 1. And so scale factor of 3, that's no good, that makes it larger. Scale factor of 3, no good, makes it larger. Okay, and so it seems like it's going to break down to like, is it going to be a y-axis reflection or an x-axis reflection? Let's take a look. Okay, well, even though it's definitely reducing, I hope we can see that we're generally going to be flipping over over the y-axis, excuse me. We're flipping left and right, right? And so the answer here has to be a the y-axis reflection. This guy right here. Because we're not flipping over the x-axis, that would be an up and down reflection. We're flipping left and right, that'd be a y-axis reflection. I didn't even have to do the transformations there. In fact, that's a big part of like knowing a bunch of geometry, is the more you know, the less you actually have to do, because you can think your way through most of the problems. All right, guys, that's part 2. That concludes the review on dilations. And so just in kind of quick like run through, the strategy was pretty simple. First, we have to kind of recognize which is our starting point, our starting triangle, which is our ending triangle. And in this case, we're going from large to small. We know that the K factor has to be less than 1, has to be some kind of fraction or decimal. And so we eliminated the K factors of 2, or the scale factors of 2. And then it seems like we just have to figure out the other part of the movement, but we've done that. So if we just grab one of the points and just test it, we should figure out if it's an x-axis reflection or a y-axis reflection. Okay, guys, that's part 2 of the video. We'll resume talking about principles of general mathematical similarity, which is exciting.